Hi everyone, welcome to a pre-calculus video about lessons 3, 4, and 3, 6. We're talking about factoring polynomials. Now, it's always a good idea to check to see if you can use a GCF or if you can factor using any special products that we know, or by grouping, or some other of the factoring things that we know about. So it's always a good idea to check that first. But this is my favorite group of steps to try to see if I can factor a polynomial. So we start out by finding out how many zeros there are. And the way we do that, we're going to use this example, is we look at the greatest power on our variables. So that's this 3. Okay, so there are 3 zeros. Okay, so that's the answer to step 1. Step 2, they said use the rational roots or zeros theorem. Depending upon what textbook you're using, it could say zeros, it could say roots. But either way, what you do is you take the factors of this last term, which are 1, 3, 5, and 15, and you divide it by the factors of the leading coefficient, which is just 1 here. Okay, and it's going to be positive or negative for each one of those. So positive or negative 1, positive or negative 3 divided by 1, positive or negative 5 divided by 1, and positive or negative 15 divided by 1. Okay, so that's step 2. And there is a purpose to that step, because when you look at your graph, which is next, what you do is you make sure that what's in the graph makes sense. So I have it typed here as my y1 graph, and it's what's going to come up on my graph. So when I graph it, what I do is I look for the places where the line is going through the x-axis, the zeros. So it looks like it's going through at -3, +1, and +5. So I'm going to write those down as probable zeros. Now, I'm going to compare these to the list I just made, because if any of them don't match, then that's a problem. That tells you that there's probably an irrational root in there somewhere. So notice this -3 is right here, this 1 is right there, and this 5 is right there. Okay, so all of them seem to work. Now, I should double check using synthetic division. You may remember that the factor theorem says if I divide by something that's a factor, my remainder is going to be 0. Now, I have a fun way of doing this that really helps out a lot with the factoring process. So I'm going to start my synthetic division. So I'm just going to copy all of the numbers from up here. So I have 1, -3, -13, and 15. And then I'm going to pick one of these to start with. And it doesn't matter which one, but I try and do the easiest one first. So if there's a 1, I'll do that. If there's a 2, so I try and pick the easiest numbers first. Okay, so I'll start off by bringing this down. Then 1 times 1 is 1. Then add. Then multiply by 1. Then add. Then multiply by 1. Then add. Now notice my remainder is 0. That's good. That means that 1 is a factor. Oops, that's a 1. Okay, that worked. Now I'll try, 5. Now here's the cool thing. I've factored out x minus 1. So I have x squared minus 2x minus 15. So hypothetically, if I didn't have anything left in this list, I could go ahead and use the quadratic formula on my a, b, and c numbers. But I don't need to because I have more in my list. So I'm going to try the 5 next. Bring down the 1. Multiply, add, multiply, add. And again, I got a remainder of 0. So 5 works. Now I'll try -3. Okay, and -3 worked as well. Okay, so I don't have to do the quadratic formula step because I had enough factors. This is an optional step. If you don't have enough factors, you would do the quadratic formula. So now finally, I'm just going to write my answer. And it depends on what they asked for. If they just asked for the zeros, this is it. But if they asked you to factor it, You would start off by writing whatever number is here. If it's a 2, you'd write a 2. If it's a 1, you'd write a 1. If it's a 1, you technically don't need to write it, but you can write a 1 times. And then it's going to be x minus 1. It's going to be x minus 5. And x minus negative 3. Okay, now I'm going to get rid of that 1 because, like I said, 1 times anything, you don't technically need to write the 1. So this is my factored form for my polynomial. Okay, that's completely factored. And if I wanted to check my answer, I could multiply all of these together and make sure I get that. Let me show you one more example. This one's interesting because we're going to need to use that quadratic formula. So, step 1, how many zeros? There are 4 zeros. Next, the rational roots theorem. I'll take factors of 4, which are 1, 2, and 4, and factors of 3, which are 1 and 3. So I would get all of these divided by 1, which is 1, 2, and 4. And then all of these divided by 3, which are 1/3, 2/3, and 4/3. Okay, now I'll check with my calculator. Let me just bring up the other graph. Okay, here's my graph. If you can see that, the light is a little bright up there. Let's see. Okay, well, it was working earlier. I don't know why we're not seeing the graph now. It's a little too bright. But anyway, if you graph it, you would see right here, it's a little less than 0. It's not like on 0, but it's a little less, and it's definitely not negative 1/2. So I'm going with, looking at my list, negative 1/3 might work. Okay, and that's why we make this list, because I can't tell what decimal that is. I know you probably can't either. So we make our list, and we'll try and guess something that's actually on the list. And then it looks like positive 2 right there. Okay. So now, what I'm going to do is I'm going to try my synthetic division. Now notice the problem. I have 2 numbers here. There are supposed to be 4 zeros. That tells me that some of these might be irrational or not real. And that's why we call this the rational root theorem. It only identifies the rational ones. So you might have some imaginary values, and you might have some that are not real. So let's try synthetic division with the 2. So I have 3, -2, -1, -12, -4. Bring down the 3. 2 times 3 is 6. Add. 2 times 4 is 8. Add. 2 times 7 is 14. Add. 2 times 2 is 4. And oh, look, it worked. Yes, 2 works. Let's try negative 1/3. Okay, so bring down the 3. Negative 1/3 times 3 is just -1. Add. Negative 1/3 times 3 is, again, -1. Add. Negative 1/3 times 6 is -2. And add. So negative 1/3, oops, 1/3 worked as well. Now we could try some of these again, but I have a feeling they're not going to work. I have 3 numbers here, so that's A, B, and C for our quadratic formula. So I'll go to that. Negative B plus or minus the square root of B squared minus 4 times A times C. Oops, let me get rid of this. All over 2A. Okay. 4 times 3 times 6 is, double check with a calculator. I always end up making mistakes if I don't double check. Negative 72. Okay, and 9 minus 72 is negative 63. Now, I should simplify this further. 63, let's just get rid of this answer, is 3 times 21, and 21 is 3 times 7. Okay, so I can simplify that by 3. So I have negative 3 plus or minus 3i times the square root of 7. The I came from this negative number. Now, all of this can reduce by 3. So I get negative 1/2 plus or minus I square root 7 over 2, or square root 7 over 2i. These are my factors. Now, to write the factored form, I need to make a little room here. Let's just get rid of my factor tree. I would do x minus 2, x minus negative 1/3, x minus negative 1/2 plus square root 7 over 2i, and x minus negative 1/2 minus the square root of 7 over 2i. Okay, so this should be up there. I ran out of room. But that would be the factored form of this thing. Okay, so that's a basic overview of how to factor polynomials using those steps. So let me know if you have any questions when you get to class, but hopefully this helps.